Hi, I'm Nichole Alcorn from the Office of Academic Affairs today.
And I'm Lisa Hubers. I am a math teacher at Tompkins Middle School.
We're very excited to be with you, and let's first start off with our mindfulness activity called 5-4-3-2-1 grounding. First, let's take a deep breath in and exhale. Deep breath in and exhale. So first, we're going to find 5 things in your room that you can see. So maybe it's a window, maybe it's the TV, maybe it's your bed. Just count 5 things that you can see. Next, let's acknowledge 4 things that you can touch in your room. Maybe it's the couch, maybe it's the carpet, maybe it's your blanket. Good job. Number 3, let's acknowledge 3 things that you can hear. Maybe you hear your siblings playing in the other room. Maybe you hear someone making lunch. So acknowledge 3 things you can hear. Next, 2 things you can smell in your room. Maybe you can smell the laundry detergent on your comforter. And lastly, acknowledge 1 thing in the room that you can taste. Hopefully it's your toothpaste since you just brushed your teeth. Now let's end with deep breaths in, exhale, deep breaths in, and exhale. Nice job, guys. We're going to get started today with our lesson. Our secret word for the day is pancakes. We all know that you love pancakes, so just please remember that word, write it down. You will need today a piece of paper, a pencil, and a calculator. So please make sure that you run and get those things, and we are so excited to be with you. Yes, we are teaching together. We have some spatial distance between the 2 of us, social distance that is, and we have sanitized our pen so when we use it going back and forth, we are not spreading any germs. So let's get started.
Okay, students, so today we are going to be talking about a 6th grade standard. It's going to be about the volume of rectangular prisms that have fractional edges. So there's some vocabulary we need to think about first. Let's think about first what volume is. Volume is the space that's inside a 3-dimensional object. Mrs. Alcorn has a little demonstration to explain what volume is. We have talked about area, which is the space inside something that's flat. Volume is the space that's inside something that's 3-dimensional. She's filling up this little box that we have, this glass box. Okay. Volume is the space that all the Cheerios took up inside that glass box. That's what volume is. So we're talking about volume of rectangular prisms. What is a rectangular prism? It's a 3-dimensional object. It has length, width, and height. And the faces at the end are the same. So this is a triangular prism because the spaces at the end are triangles. This is a hexagonal prism because, whoops, back. This is a hexagonal prism because the faces at the end are hexagon. What we're talking about today is a rectangular prism where the sides all are rectangles.
And we have lots of examples of that on the table, and I'm sure you can find lots of examples of this in your own home. So one thing I noticed on our vocabulary, I see the word 3 2 times. I see it right here, 3-dimensional, and here again, 3-dimensional. Volume, how much can it hold? And then rectangular prism, we're looking for items that have that rectangle that's on the top and the bottom.
And on all sides.
And
on a rectangle,
sides.
It's on all sides. A rectangular prism, it's on all sides. Okay. So this is some places, some other things. This rice boxes, macaroni and cheese. I bet you could go to your pantry, you could go to your bathroom closet and find all kinds of rectangular prisms.
But I think in 5th grade, we talked about rectangular prisms. I remember
exactly
that.
This is Alcorn.
Okay.
Volume of rectangular prisms is a 5th grade standard. You learned this last year, that the formula for a rectangular prism is length times width times height.
I think so. We could probably do this.
Yep, I think
because we have all those.
We do have all of those. Annotate. Okay, So first we have to decide what's the length, what's the width, and what's the height. What do you think, Mrs. Alcorn?
So the length to me would be right here, the 10.
Okay.
Does it really matter though?
It doesn't. That's the thing. If I take this box right here and you say, oh, here's the length, here's the width, and here's the height. What if I turn it this way? Now the length, the width, and the height changed. So it really doesn't matter with a rectangular prism which one you call the length times the width times the height. So I'm going to multiply this as 4 times 3 times 10. The reason I did 4 times 3 first is because I can do that in my head. Then whenever I multiply 12 by 10, I get 120. So the volume of this is 120 inches cubed.
Where did you get the 3 from?
Because whenever we say inches times inches times inches, there's 3 of those. And it also goes along with that 3-dimensional figure that we're doing.
So I see a pattern of 3 that we want to make sure that we're capturing.
Absolutely. So what's different in 6th grade? Instead of these being whole numbers, like in 5th grade, they're going to be fractions. That's what we're going to be teaching you today.
But we've been working on fractions since we were even in kindergarten.
Yes.
So we're not going to freak out about this.
That's right. You are on it, Mrs. Alcorn. So why is that not going?
There we go.
Okay. So let's review. We learned how to multiply fractions in the 6th grade. Here's a perfect example of multiplying fractions. So we have a mixed number, we have a whole number, and we have a mixed number. We want only fractions here, ladies and gentlemen. So I'm going to take my mixed number, and I'm going to remember how to change that to an improper fraction. I tell my students to multiply here, add here, start at the bottom, and work your way up. So everybody think, 4 times 3 is?
12.
Plus 3 is?
15.
And then we keep that 4 the same. The denominator will not change. Now I have a whole number. Do you remember how to change that into a fraction?
So we always know that anything over 1 is going to be the fraction version of that whole number.
Exactly.
So 2 over 1.
A whole number over 1 makes it a fraction.
Time to do that dance again, right?
That's exactly
Yep,
right.
there
Good.
we go.
Oh, I love calling that a dance.
Well,
So 3 times 1 is?
3
Plus 2 is?
5.
And my denominator stays?
The same.
Exactly. Now we can multiply cross, but remember some other things that we learned is that you can do some cross canceling to make our numbers smaller and easier to multiply. So I look at the numbers at the top, I look at the numbers at the bottom. Do any of them have a common factor?
The 4 and the 2, they're
Yes.
definitely going to go in together because 2 times 2 is 4.
That's right. So 2 goes into 4 twice, 2 goes into 2
One
once.
time.
Anything else?
I see one other thing, 15 and 3. I know that 15 divided by 3 is 5. So 5 on top, and then there we go, 1.
Exactly.
Oh, much better.
Now, some people think that you can't cross cancel those because they're not next to each other. That's not the case. It has to be at the top and the bottom, boys and girls, not next to each other.
Okay.
Okay, and we can't cross cancel the 5s. Why not, Mrs. Alcorn?
Because they're on the same, they're
Yes.
both the numerator.
They're both at the top. Remember, 1 has to be at the top, 1 has to be at the bottom. So 5 times 1 is?
5
Times 5 is?
25.
Very good.
It's a lot of math
2
today,
times
guys.
1 is?
2.
Times 2 is?
2.
Now, this is an improper fraction. It's okay sometimes to keep it that way, but let's just for review, remember how to change it to a mixed number. We need to know how many times would 2 go into 25. Do you know, Mrs. Alcorn?
Well, 2 times 10 is 20. So I'm liking that where that's going. I would say that we would want the 10 on the, we'd make that the whole number, correct? Or
It can go in a little bit more. 2
Really?
can go into 25 more.
yeah, 24.
That's right. So how many times will 2 go into 24?
12.
With how many left over?
Well, 25 minus 24 is 1.
Right. And so this would change it to 12 and a half. So that's just a quick review of fractions. We learned that probably in about September of this school year.
Yes.
So we learned volume of rectangular prisms in 5th grade. We learned fractions in 6th grade. We're just going to put it together, boys and girls, and we're going to talk about fractional rectangular prisms with fractional edges. Nothing new here.
So we know we're going to multiply length times width times height, and this time we're just going to add in those fractions, just putting that all together. So we see fractions here. We also see a whole number, and we know finding the volume is length times width times height. So we have everything that we need to solve this problem.
That's exactly right. By the end of this lesson, ladies and gentlemen, you're going to be able to say, I can find the volume of rectangular prisms with fractional edges. That's our goal. Here we go. So let's take this problem and think about that every time, how to do that. Okay, so I'm going to start off with, what should I multiply, Mrs. Alcorn?
2.5 times 4 times 7.5.
Okay.
Now, I want to make this easy as possible for our learners today. I think we need to make all of these into fractions. And this is already a fraction, but let's make it into an improper fraction. So there's going to be a bigger number over a smaller number. Time to do our dance.
2 times 2 is
4.
Plus 1 is
5.
Denominator
2. We're just pulling that 2 down. A lot of people forget to bring that down. Bring that 2 down. Oh, here we go again. 4 over 1.
Voila.
Super easy.
Magic.
Time to do our dance again. 7 times 2, 14. Plus 1, 15. Pull that 2 down.
Exactly.
Now, Miss Hubers loves to make things easy for people, and so she is going to want us to go ahead and reduce this already. So what? I see one thing. Do you see anything else?
I do. I see that both 2 and 4 are even.
Yes.
2 goes into all even numbers. So 2 would definitely go into 2 once. 2 would go into 4 twice. This is an odd situation, but this can happen. Look how these are both 2s. What can divide into 2?
The same number, so it would be 1.
So you can double cancel. Not a problem. As long as it's at the top, 1 at the top and 1 at the bottom. So let's multiply. Oh, what about that 5 and 15?
Well, see, that wouldn't work because it would have to be on the bottom, and they're both on top, so that's not going to work.
So 5 times 1 is 5, 5 times 15. If you don't know that, boys and girls, you can write that down. I happen to know that it is 75. And then 1 times 1 times 1 is 1. And so that would just be 75. Our unit is inches times inches, which would be inches cubed. So you see how we took our 5th grade standard, volume of rectangular prisms, our 6th grade standard, multiplying fractions. We put it together, and we have our new 6th grade standard, volume of rectangular prisms with fractional edges. Okay, got another one for us, Mrs. Alcorn.
Okay.
Oh, I forgot. I have a little joke for you, Mrs. Alcorn.
What's a teacher's favorite tree? Are you talking about a math teacher?
Absolutely.
Okay. Symmetry?
Oh, that's a good one. Nope, that's not it, though. It's a geometry. Okay.
We just thought we would break it up with a joke because you guys have been working so hard with fractions and multiplication.
And
it's a lot.
thank you for your hard work. I know this has been a challenge for everybody.
Oh, I don't see fractions this time.
What?
I see decimals.
Oh, well, Mrs. Alcorn, we do have to remember that every decimal is indeed a fraction. Just like every fraction's a decimal. Mrs. Alcorn, how do you say this decimal right here?
2 5/10 because the 5 is in the tenths place. So that would be the same as 2, whole number, 5 over 10.
Isn't it weird? Those look so different, but you say them the exact same way, 2 5/10. How would you say this?
That would just be 4/10.
That's right.
There would not be anything in front of the whole number there.
What about this one?
3 2/10.
Perfect, Mrs. Alcorn. You must have been paying attention.
I have been. I've been practicing.
Okay, so before we use these fractions, though, to find our volume, I noticed that both of these numbers have a common factor. Is there something I can divide from 5 and 10?
Well, 5 times 2 equals 10, so we divide by 5 on top.
Exactly.
Whatever you do on top, you must do on bottom.
Exactly.
So 5 divided by 5
is
1.
And 10 divided by 5?
2.
And our whole number didn't change. What can I divide from 4 and 10?
That's that very famous 2. 2 goes into our even numbers.
That's exactly right. Good memory. What's 4 divided by 2?
2.
10 divided by 2?
5.
And what will go under 2 and 10?
Same thing on top, except this time we're going to be dividing by 2.
Okay. Which will be 3. 2 divided by 2 is
1.
10 divided by 2 is
5. So we've made it
fractions I'm going to use.
way easier to work with.
Yes. So here I have 2 1/2 times 2/5 times 3 1/5. But I don't want mixed numbers. Mrs. Alcorn, what do I want?
We want to go ahead and do the dance again. We're going to change those to improper fractions.
2 times 2?
4
Plus 1?
5
Denominator?
stays the same, 2.
I don't need to do anything with that fraction. It's already good to go.
Time to do the dance again.
5 times 3?
15
Plus 1?
16
Denominator?
stays the same, 5.
Awesome. Very good. Now I take a look at this. Is there anything that I can cross cancel? Remember, it's got to be 1 at the top and 1 at the bottom that has a common factor.
I mean, it's like sticking out big time.
It sure
5 and 5, those are the same. Divide by 5 and you get 1.
Exactly.
And I see the same thing here, 2 and 2. Divide by the same number and get 1.
Exactly.
So,
now you could have done the 2 and 16, but you can't do it twice. Only if the new number can cancel. So we're just going to have to leave it like this, okay? So Nichole, Mrs. Alcorn, 1 times 1
1
times 16.
16
1 times 1
1
times 5.
5.
Remember what this line truly means, Mrs. Alcorn?
To me, it means division.
It does.
Okay, good.
All right, good answer. How many times does 5 go into 16? Divide into 16.
5 times 1 is 5. 5 times 2 is 10. That may work, but I think there's something better. 5 times 3, 15.
That's exactly
So,
right. So my whole number's 3.
3.
How much is left over from 15 to 16?
16 take away 15 is 1.
That's my new numerator, and guess what stays the same?
5.
So 3 and 1/15. Same unit. It will
Inches
not
cubed.
always be the same unit, ladies and gentlemen, but the problems that we chose are.
And what do you mean by unit?
The unit is the measurement.
So it could be
like
feet.
centimeters,
Okay,
feet,
got it.
yards, miles, whatever.
Well, that was a lot of work,
That sure was a lot of
but
work.
we did it. We never gave up. Okay, we're going to give you guys the chance to do this at home. So volume, to find the volume of a rectangular prism, you're going to be multiplying length times width times height. We're going to play some music for you guys as you guys are working. We're going to give you a little bit of time, so grab that pencil, that paper, and a calculator if you need it. So if
Okay.
you go there and
I forget.
back. I think it's back.
Back, yes, okay.
And
Here's the
then
music.
is there. Perfect.
Okay, so boys and girls, while you were practicing and listening to some music, I went ahead and worked this out. I had a fraction times a mixed number times a whole number. I changed my mixed number to an improper fraction. I changed my whole number into a fraction. Notice there was nothing here across cancel. That will not always happen. When it does, it's great because it makes the problem a little easier, but in this case it didn't. My answer was an improper fraction. I changed it to a mixed number. And I put centimeters cubed because this time my unit was centimeters times centimeters times centimeters. Okay, here we go. So, do we have time for another one?
I think we're going to go ahead and stop. You guys have been doing such a great job. Just a reminder, everyone, that today we were figuring out how much volume would fill up a box. And so today we thought we would talk a little bit about some of your favorite things. Some candies that maybe you get at the movies. And we're going to watch a little clip right now of all about, are those boxes filled when you go to the movies?
So let's see. This gentleman has done a little experiment where he opened some boxes to see how much candy is in there. Let's see what he found out.
First thing we all do, right? You grab a snack. If you're anything like me, you head straight for the candy. It is so tempting, isn't it? You can't see inside the box, so you shake it up, and you may assume it's filled up. But now new class action lawsuits just filed against some of the biggest candy brands, claiming the boxes are underfilled. So how much candy is actually in there? This morning, guess what? We're cutting the boxes open to find out. We all need
The boxes open for you. And so we're going to do a little experiment right now. Just take a guess out of all the candies that are up here, which one is going to give you the most, because none of them, I repeat, none of them are actually filled by volume. We found out they're filled by weight.
Yes.
So we'll go ahead and show you what we found.
And some of the boxes even say that, filled by weight, not by volume. So you can grab one too, Mrs. Alcorn. So I cut these open. I could kind of feel how far down the candy went, and I cut it open to see how much candy is actually in here. Look at that.
There's a lot of extra space up here.
At least a third of this is empty. Whoop.
So we're going to take a look at these two boxes. You're going to...
Yeah, I know. Oh, Milk Duds.
Milk Duds. That's a good option.
Okay, and the very worst was the Sour Patch Kids. Look at that.
And I know how much you guys love Sour Patch Kids.
Less than half full. So you can see there's a lot more volume in these boxes that could contain candy. Now, we're not trying to bash the candy companies or anything like that. We're just trying to explain to you what volume is. It's the space inside. Obviously, these candy boxes are not full of candy all the way inside.
Okay, and so lastly, if we can get back to our presentation, I found also out on YouTube that there's tons of things you can do with cereal boxes, that you can make a ton of options. You can take this and make it into a folder. You guys can get ready for the next school year, or maybe if you're doing some fun activities at home this summer for school, you can make a cereal box folder.
Next one?
No, just up here. There's a cereal box document organizer, and then this is even for any of the girls who have makeup, they can actually make a little makeup box. So,
or jewelry.
Yes, or jewelry. There's just lots of options with cereal boxes. Who would have known? You guys did a great job today. What
do they need to search? What would be the search words to find these?
What to make, or how to use your cereal boxes.
Cereal box crafts.
Cereal box crafts, yes. And there's so many options. But going back to closing up our activity, what was our goal today, Ms. Hubers?
The I can statement was, I can find the volume of rectangular prisms with fractional edges, and I think we were pretty successful.
I agree, and don't forget that your secret code word today is pancakes, so please make sure that you write that down. Thank you so much for your hard work. We really appreciate it.
Stay active, boys and girls.